Okay, welcome my student to our course Electrical Circuit 2. We'll continue our course uh, today starting with chapter 24, which is about polyphase system. We will arrange the topics, the most important one, then we'll study the other one by one. In polyphase system, we will talk about this point, three-phase generator and Y connection type and delta connection type, since it is a three-phase system, and then how to connect Y connection with delta connection, either source or load, because we have source three phase and load three phase. We have four options to connect them, either Y connection, or Y delta connection, or delta connection, or delta Y connection. uh, the system here, three phase polyphase, we concentrate about three phase system because it's the most we got the efficiency more when we use three phase system. We have more than three phase system, but the best one is a three phase system in term of transmission, in term of in the load, for example, for the motor running and starting characteristics, and other feature, because this most of the equipment or systems in the world, it is a three phase system. When we generate electricity from the generator, three phase generator, we will have a three phase waveform. The first one we call it EAN. Let us use the pointer. The first one is EAN, the second one EBN, the third one is ECN. As we know before the midterm, when we draw the sine waveform, and this is the first one, and there is, you will not notice that between phase AN, EAN and EBN, there is shift between them 120 degree, and it's similar between EBN and ECN. There is shift between them 120 degree. Okay, between each phase and phase there is shift 120 degree. We can draw this waveform as a vector, or the value of the voltage or current later as a vector, and if we consider EAN as a reference starting from 0, then EBN and ECN, between each one and the other 120 degree. We will see later different sequence. This is called positive sequence here, EAN here and EBN here and ECN here. We will see the negative sequence if it is EAN here and ECN here and EBN here. Later we'll discuss about this. But this vector, how to draw the waveform. For example, if our sinusoidal waveform starting from 20, not from 0, this means EBN will start from 140, not 120, and ECN will start 260. Okay, and similar here, when we draw this, for the example, start EAN start from 20 degree. Okay, ECN will be here in 140, and EBN it will be 260. Okay, we will solve many examples inshallah later, but now only to explain the concept of a three-phase system. As we said, the vectors or the sinusoidal waveform, we can express this as as sinusoidal expression. Since there is 0, start from 0 AAN, then we will write EMAN. This means peak value for the waveform, for the phase value, sine omega t without any angle. The other example, when we say 20, if it is 20, we will write here minus 20. Okay, my student, if we write minus 20, we will here start in plus 20 here, as you know before the midterm when we solved electrical circuit single phase. And similar here, since we have a phase shift between each phase and phase 120 degree, you can notice that we wrote here the phase shift 120, and for ECN we wrote 200 minus 240. Minus 240 we can write it plus 120. You can see here plus 120. This means if we go clockwise, it is minus 240. Okay, for ECN, and for EBN it is minus 120, or you can write it plus 240. You can see this in some books. If we need to write these sinusoidal expression in phasor form, as we know before, you can write it easily. You see here bolded, and then EAN angle 0, for EBN it is the magnitude for EBN and the angle minus 20, which is the same here, and here ECN the magnitude for ECN and plus 120. In general, because a three-phase system, we have two types of a three-phase system. Either it is balanced system or unbalanced system. In our course, we'll study the balanced system, and when you add EAN and plus EBN plus ECN, you will get the value 0. I don't mean the magnitude. You will add the phasor form, the magnitude with the angle, the magnitude with the angle, the magnitude with the angle. You will try any example later. You will find summation of the three phases. You will get 0 value. Don't forget about peak value and RMS. It's different than a three-phase system, and what we will talk about. But to remind you, when we talk about single phase, we have peak value and RMS value. The peak value, which is EM for phase AN, if you multiply by 0.707, you will get the RMS value for this phase. I will show here. See here the RMS value. If you multiply, or this is not clear, but here, if you have the peak value, any peak, you will multiply by 0.707, you will get the RMS value for each phase. Because it is balanced system, you will get all the value for the magnitude the same. You will not find different value in the magnitude. Only the change will be in the phase shift between them. Okay, and we know that between each phase and phase 120 degree, either positive sequence or negative sequence. When we start talking about three-phase system, because it is a three-phase system, we need to connect each phase to the other, and we have two type of connection. Either Y connection, this is called Y connection, or it has other name called star connection. When you see in any book Y connection or star connection, direct you will consider it as Y connection. Okay, how to know this is Y connection? Even if we change the shape of the connection, you will find all the phases connected in one common point, and the other terminal for each phase go to the load. We will consider this as the source. Okay, as it's written here, Y connected generator. This is the load. Then we will talk about either it is connected as Y connection or delta, but we will explain here some information about three-phase system, and the voltage value and current value, because we have three-phase system, we have two type of current and two type of voltage. We will see it here. In general, any current going through the line between the source and load, we will call it I line. Okay, and any current going through any impedance, either it is resistor, inductor, capacitor, or resistor, inductor, any current going through the impedance, we will call it I phase, current phase. We will put this, do not this by phi, it's considered as phase if you see it, or we can write sometimes I phase like this. Okay, when we write here I phase G, this means I phase in generator side. Okay, or we can write I phase G. Okay, some books write it like this, or some but you will know from by when you will know what do we mean by when we write I phase or I line. But you need to distinguish between them, because now it is easy to decide I phase going here and going in the line equal each other. This means we can write I phase equal I line, like it's written here. Okay, since it is Y connection, this is only in Y connection. It's similar for voltage. We have two type of voltage, either voltage phase, which is EAN, EBN, ECN, which is the voltage across the impedance, the voltage across the impedance. Any voltage across the impedance, we will call it I phase. As we said, I will repeat this information. This is the balance system. The value for voltage equals the difference in the phase shift. The other type of voltage, which is called voltage line, similar to I line, but the voltage line, when we need to know where is the voltage line, if we need to put the voltmeter, for example, if we need to consider here in the lab later to measure voltage phase, we will put the voltmeter here. Okay, and if we need to measure voltage line, we will put the voltmeter here between each line and the other. This will give you voltage VAB. Okay, and here you will get other voltage, which is VBC. Okay, and we can draw from A to C voltage ACA. Okay, my student, now we distinguish between voltage line, current line, current phase, and then voltage phase and voltage line. Now, since we know that there is difference between voltage phase and voltage line, this is the voltage phase and this is a voltage line. As we said, EAB, ECA, EBC. Okay, we know that in the black one, it is a phase voltage. Between each phase and phase there is 120 degree. There is 120 degree. Okay, but for phase and line, always the difference between them, the phase shift between them, 30 degrees. Okay, consider this for all Y connection. Okay, 30 degrees between each phase and each line. If we need to write also, before we go to the formula, also the relation between phase value and line value, it is root 3. If you multiply phase value by root 3 and Y connection, you will get the line value. If you remember in the lab, 120 voltage, it is connected from line 1 to N, or 2 to N, or 3 to N. This is considered as phase value. If you multiply 120 by root 3, you will get 208, which is line to line value, which is 1 to 2, or 2 to 3, or 1 to 3 in the lab equipment. Okay, now if we need to add this information and this information together, we can write the formula here, which is called EAB, which is line voltage, equal root 3 EAN, as we said here, as a magnitude value, and the shift between them 30 degrees. What about ECA, sorry, line voltage for CA? You will multiply phase value for CN with multiply by root 3, then add 30 for 120. If you remember here, it was 120. Okay, this means 120 plus 30, you will get 150. And here for BN, it was minus 120, this means 240. If you add 240 plus 30, you will get 270. Okay, this is the relation now between phase value with the line value. Okay, this consider this only in Y connection voltage phase, but for the current phase and line, they are equal each other, even in the angle. Later we will see. What about if we need to write EAB, ECA, EBC in the sinusoidal expression? We will multiply root 2. Don't forget, if you multiply root 2, you will get, because this, it is RMS value. All these are RMS value, since it is phasor form. If you multiply phasor form by root 2, you will get peak value for line value, sine omega t plus 30, since here it's written 30. Root 2 multiply ECA sine omega t plus 150, and here plus 270. Some students will ask how we got the relation between the phase value and line value. We will see here from the from the vector connection. We will see this next slide. See here, it is the same as before, but without all the line value. Only we draw only one line value, which is EAB, between EAN and ECN 120, 60 plus 60. And here between EAN and EAB, it is 30 degree, since 60 here and divide by 2, we will get the beta angle between the line and phase 30 degrees. Okay, if we divide to be able to use this formula for trigonometric, okay, you will find, if you, for example, you need to find cosine theta here. Here we know that beta here 30 and here beta 30. Consider we need to find cosine 30 here. You will get this value, which is x, this value x and this value x. This means later if we need line value, line voltage, we will multiply x by 2, because here x and here the other x. Okay, cosine 30, it is x divided by NB, or we can say here cosine 30 x divided by EAN. If we arrange it, x will be, okay, EAN multiplied by cosine 30. EAN we will not change it, but cosine 30, if you calculate it by calculator, or you will get, it is root 3 divided by 2. Now we have 1x. If we need 2x to get the line voltage, we will multiply x by 2. You will get EAB. If you multiply by 2, x, the 2 will cancel with this 2. The relation will be root 3 phase multiplied by phase value. Okay. Here we will talk about positive sequence and negative sequence. This is called positive sequence and this negative. Okay. How to distinguish between positive sequence and negative sequence? If you put fixed point here and rotate your vectors counterclockwise, who will cut the point first? It will be cut by EAN first, and then EBN second, and then ECN will come here. This means positive sequence called A, B, C. Okay, and here negative sequence, we change this ECN and EBN, we will change it here EBN and CN. If we rotate the vectors counterclockwise, you will find EAN cut the point first, and then ECN, and finally EBN. This means A, C, B, the positive sequence. Okay. If you want to write the formula now, it will be changed. This is the first one before, as we wrote before. It is EAN 0, it is BEN minus 120, CN plus 120. It will be here opposite. ECN, it is minus 120, EBN plus 120. Okay, and you know, our reference here, our book, Introductory Circuits Analysis, 13th edition. We stop here, and we'll continue a lecture, the second lecture, with section 20, chapter 24.5 in the next lecture.